everyone, welcome to the explanation. So in this is the continuation of our video data structure lecture series, and in previous video we discussed about classification of data structure. So I think we classified our data structure in two types, that is primitive data structure and non-primitive data structure. So if you have not gone through this video, please go and watch in our playlist. So in non-primitive data structure we had two types, that is linear and non-linear. Okay, so in linear, again I'll be writing here. So in linear data structure, we had array, linked list, stacks and queues. And in non-linear data structure we had trees and graphs. Okay, so if you have not gone through, please go in the go and watch the previous video. So here in linear, the data is arranged in linear fashion, we can say, and there is a linear relationship among the element. But in non-linear data structure, the data is not arranged in sequential order, they are in hierarchical order, we can say. So these are the 6 types of data structure, we can say. So in this video I'll be discussing each data structure in detail along with their advantage, disadvantage and applications. Okay, so sometimes some questions are asked, these are very basic thing, but sometimes some questions are asked from these topics and students get confused. So today let me cover these basic things and then we'll go further in our data structure algorithm. So let me start with array. Okay, so array, I think you have already studied in C programming, so there will not be any difficulty for this. So here array is a data structure, we can say. It is an arrangement of element. Array is a collection of element of similar data type, we can say. Similar data type in adjacent location. Okay, so it always stores elements of same data type and they are linear, we can say they are linear data structure. Linear data structure as well as homogeneous type. Homogeneous means same type. Okay, so how it is indicated? If you see, it is indicated like if you are giving your array name, suppose A, so if its size is 5, then it is indicated as like this: 1 2 3 4 5 curly bracket close. It means that in memory, if you are going to see, if the name of memory is A, then 1 2 3 4 5, so 1 2 3 4 5 will be stored here. Okay, if you see the memory location, so suppose it is of integer type, yeah, so it will be increased by 2 byte. Suppose the address of this location is 2, the next will be 4, then 6, then 8, then 10, like this. Okay, so again next there are types of arrays, we can say. Okay, so we can say there are 3 types of arrays, yeah. So first is one dimensional array. So these are the array in which there is only one row, that I already have told you. Then there is 2-dimensional. Okay, so in 2-dimensional array there is one row and one column. So these 2 types of array we have to study. And in multi-dimensional array, you know, there are more than 2 dimensions, we can say. Okay, that is multi-dimensional. Fine, so let's come to the main point. These are some of the basic things of array. Let's come to the main point. So I'll be writing the limitations, that is disadvantage and applications of all these types of data type. So let me write the limitations, why we need other types of data structure. So going for the limitation, so first limitation of array is it is of fixed size. Okay, the size is fixed here, and the data are always stored in, we can say, contiguous memory location. Okay, what is contiguous memory location? One after another. Okay, so for example, this is your array, then one after another. First element will be stored here, second will be stored here, third will be here, like this. Fine. So this limitation can be solved by using another we can say data structure which is called linked list. So this we'll be studying later. Let's go to the application of array. Okay, so this question sometimes they ask and the students get confused, although this is a very basic thing. So going to the application, this type of data structure, where it can be used for storing data of same type. Okay, it can be used in storage of matrices. Also it can be used in storing, I think, binary, binary tree element we can store here. Okay, so these are the limitations and these are the applications of array, we can say. So due to some limitations in array, we are going to our next data structure, which is nothing but two number, which is nothing but linked list. Okay, so what is linked list? Okay, so linked list is a data structure type, we can say, in which each element contains a pointer, we can say, or link to next element. Okay, so we already discussed in previous video, very basically we discussed in previous video. So linked list, if you can see, it is something like this. Okay, this is one example of linked list. Okay, so you can see that. So here, okay, here it contains the data and it contains the pointer field which points to the next, we can say, node. Okay, so all these are called node 1, node 2, and each node has two parts, data part and pointer part. So data part, suppose we have to store 1 2 3 4, so we can store 1 here. Okay, and next this pointer will point to the next node where we can store the next element. So 2 will be stored here. Again it contains the pointer. So there are two parts, nodes and pointer, and each node has data part and pointer part. Data part, we can store data, and pointer part, it points to the next address. Okay, now going to the limitation of this. Okay, so advantage of this will be, it's very, let me write advantage of this, it's easy to insert and delete data here. So while studying the operations in linked list, we'll see that how easy it is to insert and delete the data. The disadvantage will be, it's very slow search operation. The searching is very slow in linked list, and also it requires more memory space. So every disadvantage of one data structure type leads to the next data type. Okay, fine. So these are the advantage and disadvantage. Going to the application. Application means where it is used in real world, where we can use this. Okay, so it is used in implementation of, if we are going to implementation of stack, queue, tree, graph, we can use this linked list. Okay, also uh, there are certain types of linked list we can see. Okay, later we'll see that the circular linked list is there, doubly linked list is there. So circular linked list, it is used to implement circular linked list is used in implementation of OS, operating system. Next, doubly linked list. Yeah, this is a very good example. Doubly linked list, it is used in implementation of forward and backward button in browser. Okay, so this you will understand. Once we study doubly linked list, how we can go forward and backward in doubly linked list part. Okay, let's go to the third data structure. Let me get some space first. Okay, let me quickly go to third data structure, which is nothing but stack. Fine, so stack is a type of data structure. Stack is a data structure in which insertion, it will be T, I think, insertion and deletion of element is done at only one end. Okay, and can you see only one end, that is top of stack. Okay, so can you say in which structure we are going to store the data? So it works on the principle of LIFO. Okay, so what is LIFO? That is last in, first out. Yeah, so if you see the picture of stack, it's something like this. So this is the top and this is the bottom. Okay, so if you are going to store 1, 2, 3, 4, 5, 6, so 1 will be stored here, 2 here, 3 here, 4 here, 5 here, 6 here. So you can see that the element that was stored in last, while taking out, it comes at first. Okay, so while inserting, this was first, but while popping it out, this is the first. Okay, so this we'll study in detail. So right now I am just discussing about the application part and advantage and disadvantage. So let's go to the application part of this. Okay, let's go to the application part of this. So where it is used? Okay, so it is used in temporary storage. So in many applications where we have to store temporary storage of element, where we have to do temporary storage of element, in that case we use stack. Also it is used in recursive functions. If you have studied C programming, so in recursive function we have used stack again. So next, yeah, very important thing. So it is used in conversion of infix to postfix. Okay, so I have posted already the video of infix postfix conversion and all in my playlist. So once go and watch that. Also it is used in depth first algorithm. Okay, it is also used in backtracking. Okay, problem based on backtracking, we can say. Fine. So next application, I think it's fourth number data structure, which is queue. Okay, so queue is a data structure in which element that is inserted first is to be taken out first. It means that the element which is inserted at first, that element only comes out first. Okay, not unlike stack where the first element to be inserted was last to be taken out. Okay, so it is based on the principle of FIFO, which is first in, first out. If you see the diagram of this, so this is the diagram of Q, we can say. So this is the front part and this is the rear part, we can say. So from here the insertion will take place, and here deletion will take place. Okay, if you are going to insert 1 2 3 4 5, so if you insert 1 2 3 4 5 like this, so first inserted, first come out. Fine, so let's go to the application part of this. So where it is used, where we can use Q. Okay, so it is, first of all, it is used in breadth search operation, we can say breadth first search or breadth search operations in graph. Okay, so it is also used in job scheduler, we can say scheduler. Okay, job scheduler in OS. It is used in CPU scheduling and disk scheduling. It is also used in call handled by customer in BPO. Yeah, there are many applications in real world where you can use this Q. Let's go to the fifth type, which is tree. Okay, so here a tree is a data structure in which elements are organized in form of branches, we can say, or hierarchical order, we can say. Okay, so here the elements of tree are in sorted order. Okay, sorted order, we can say. So it imposes a hierarchical structure. Okay, hierarchical structure, we can say. So here in tree you can see that the example is this is a root node and there will be children's, again children's. So elements are stored here in like this: 1 2 3 4 5 6. So how the elements are stored, how it is sorted, we'll see later in the trees video, when I'll make that video. Right now let's go to the application part of this. Okay, so it is used in, first application is, it is used in code generation. Okay, for example, code generation, for example, Huffman coding, we will be seeing later, Huffman coding. It is also used in gaming application. It is used in hash trees. It is used in implementing of AI, robotics. Okay, so these are some of the applications of trees. Last type, data structure type, is graph. Okay, so it is also non-linear data structure. We can say that here in graph all data are stored in hierarchical order only, hierarchical order. Okay, here in graph the data element is called vertex. each data element, we can say each data element is called vertex and is connected through edge, we can say. Okay, so it's like something like this. Suppose this is a node A, this is node B, this is C, so it is connected like this, this D, this. So this is called vertex and these are called the edges. So quickly let's go to the application part of this. Let's go to the application part of this. So here it is used in GPS, global positioning system, we can say. Next, it is also used in some mapping applications. Nowadays it is been used in neural network. It is used in robotic motion, we can say. Okay, it is also been used in e-commerce applications. Fine. So these are some of the types of data structure. These are the major data structure, we can say. So in this video we studied about the applications where they can be used. So in the next video I'll be covering operations on data structure, some basic operations. So we are just studying the basic part of data structure. So later I'll be making video on other topic also, and we'll also be covering the old question discussion series for this, which will be useful for example. So stay safe and stay tuned. Thank you.